Thank you, Martin. That was fantastic. Okay, let's move straight on to our discussion then. We have just a few prepared questions. I think, Yoni, you have the first one. Feel free to go ahead.
Yeah, okay. So I want to open up the discussion with a sort of high level question for the both of you, which is that there's this notion of solving, quote unquote, a task domain. Maybe it's object recognition or computer vision generally. And I'm curious what that means to you, if it's a idea you prescribe to, or how you kind of conceptualize that concept.
It's a good question. It's also really challenging because I think different people have different things in mind when they talk about like what they mean with like solving a certain problem, right? I mean, I think coming more from the eye perspective, you kind of solve a problem when you've kind of reached like a ceiling performance in your benchmark, but that's not necessarily, I think, what we have in mind when we mean solving. So if you're thinking about like solving vision, I think that involves a lot of different components, right? So I think what the point where we're currently at, and I think that's in itself a really exciting thing, is that we're moving very much closer to solving what has been termed as core object recognition, right? So that's just our ability to understand or actually have a system available that allows us to distinguish between all the different things that we're actually like able to perceive and that we are actually able to distinguish from a purely AI point of view, right? Like translating this to a understanding like how this is done in humans is obviously a different question. I was recently thinking about like what are actually the different components that we need to solve if we want to solve vision, and I was kind of thinking there's probably like 5 or 6 components. So one is like the stimulus, and that's something that we've been focusing on a lot. So this is something that I think both Kristen and I have really been trying to study. Kristen obviously in like more dynamic, first person point of view, really exciting, really like forward looking. For me, making a bit more like modest, doing this with different objects. But obviously there's different tasks that people can carry out on these different stimuli that you're seeing around them, right? And with tasks, I mean, like, what is actually that you're supposed to be doing with these things? So what's like your intention, but then also the effector that you're using, like how you're actually going to be solving this. So this is like another component which can be solved with like, and these are separable components, right? Then this current state that the person is in obviously matters. So this is like the history effect, but also the context that you're currently like in, right? Like interacting with an apple on a table can be very different than interacting with an apple that you have in your lap, right? So, so that is another component. And apart from that, obviously, there's differences between different individuals. That's something that some variants we may want to take into account. And then the just general state of the person that the person is in. So if you're looking at it at this perspective, it's actually, I think we're pretty far from solving vision. But I think we're getting like a lot closer with like the initial steps that we've made.
Kristen?
Yeah, I mean, this is great. I think as far as solving, what comes to mind for me, like when do we know it's solved? I think it happens kind of in the field slowly and cumulatively, but I think it's when some piece of tech in AI becomes something that can be leveraged downstream, such that it starts to feel off the shelf. And yeah, we can assume such and such kind of detector, and it gets, in a particular method or methods and gets picked up that way, then you can start feel that it's getting solved. I think so. We have that, as a signal of like, okay, we've moved on, and now this is being used to build something else that's, different, harder, and other new ways. And then for benchmarks, I think there's like the, benchmarks such as ones that are associated with a data set is kind of a sanctioned way to like use it and a task to perform, and then the community comes together. I mean, we know these have been so important for driving progress in computer vision for many years now. And I think you can watch that progress there. It's a different notion of solved because it's solved, for the task as the benchmark lays it out. But usually good benchmarks come in, everyone's methods are pretty terrible at them. And then, you start seeing bigger leaps, and then maybe the solving of the benchmark comes when it's really more about just little tweaks to eke out in the numbers, the very best. And I think it's a really wonderful thing. We seem to see that happening, over the last years for different benchmarks. And so that's another way to think about solved, although it's more, it's in a benchmark specific way. But they're so valuable for driving the progress. At the same time, we have, I think anyone, working on a benchmark, creating a benchmark is aware it's a double-edged sword. Like we have to be careful of, being mindful of the broader context of where the tasks need to live, and not over tweaking once we're done tweaking, as a field on a particular task. So it's, the double-edged sword being, it's going to drive progress, but it's also going to focus progress in a very specific way. So we have to be conscious of that, and then the broader context of solving what matters. And then finally, the thing I wanted to mention is, I think when you think about solving, it means knowing what the right formulation of the problem is. And we are more mature as a field in certain areas than others for doing that. And I do believe, like in activity and human activity and video, this is a hot question itself of like how to formulate the problem. Is there a taxonomy? What is it? If there's not, how do we keep this open world? What are the natural, the natural ways to describe activity that matter for an AI system? I mean, there's just so many questions that we're in the thick of right now. And so that, I think, goes hand in hand here with like, how do we know if we've solved? Well, what should we be solving? And people are still finding creative ways to like pin that down.
Awesome. That's really informative. Maybe building on this and thinking about the progress that we've been able to make using benchmarks like the ones that you've led development of. I'd like to invite you both to expand on some of the themes that came out in your talks and how you see these cognitive AI benchmarking efforts fitting into the broader landscape of contemporary research in cognitive science, say neuroscience and AI. Like, do you see these kind of efforts being something that you wish more of your colleagues were engaged with? Do you think the balance of like who's building these benchmarks relative to those, using them is about right? In general, how do you think of like what a healthy ecosystem looks like in your fields and the role that you want benchmarking to play?
I could start here, just something short. I mean, I think for a healthy ecosystem and how to do, I mean, one thing that I really value and I think made, Eco4D what it is how broadly collaborative it was. I mean, I already pointed out how important it was for like the data itself, but also all the minds involved and the perspectives involved. It was a very, collaborative effort from the start, like kind of mission focused. So we came together with like a certain target of scale and breadth, et cetera, at the beginning, but then very collaborative, many voices from senior PIs to students to industry researchers, who came together. And I think that was definitely an asset for us, both for getting the job done, but also to have like that, that time and breadth of perspective to form it. So that's something I would highlight there. The second thing I'd say is from where we're coming from, an ongoing challenge is to make sure we are connecting with communities beyond computer vision. So it's happening in an ad hoc way, just, as people learn about this data and they have their own, research challenges and how they can leverage it to do that. I think robotics has been a standout so far in that regard. But I think in cognitive science and learning from the needs and problems there, and then understanding how to communicate about our data or what we should be doing next with the data. Anyway, that's a channel I think we could deepen, and a venue like this is maybe one step towards doing that.
Yeah, this is great. I mean, like, I think there's, I'm resonating a lot with what Kristen has been saying. I think, like, since you asked, like, in relation to what I was just saying, I would be actually really happy if people, even in cognitive science, were actually engaging a little bit more into some like benchmarking efforts, or actually being like using specific types of benchmarks. And I think they're still like shying away a little bit from this, because they're not necessarily, it's not something I'm familiar with. It's also like a very different way of thinking about like addressing certain problems in cognitive science. At the same time, like there's obviously like a fear or a concern, and a concern that I'm sharing is that that by just chasing a benchmark, when you're actually trying to understand like mechanisms, then just showing that your model is performing very well may actually not be sufficient, right? So that's a crucial difference, I think, between like a typical machine learning approach, which is like just focused primarily on performance. I mean, of course, like this explainable AI, but it's like a separate topic. Whereas like in basic research, really the focus is much more on understanding, right? And then people might disagree what it actually means to understand. Some people say prediction is sufficient, but other people might say no, it's actually something that you need to also be able to describe with actually comparably like few words, and it's not something that like where you can just throw like 100 million or 100 billion parameters at a problem and then say like, oh, now I understand how this is working.
Yeah, I think those are both incredibly eye-opening, thoughtful remarks. So this is, I think, for time, our last question. A bit of a challenging one. It's been somewhat pre-anticipated in your responses, but the question is, do you think there are things that in some ways we might miss out on when we take these sort of large-scale benchmarking approaches? And if so, what do you think we could do to mitigate those limitations? And just for a little bit of context, you know, the kind of classic way that science has unfolded for many years is, you know, you try and disambiguate between different hypotheses, and you control as many variables as you can. You tweak one thing and you see how your variable of interest changes. And when we take this sort of large-scale naturalistic benchmarking approach, we sort of take a radical departure from that kind of classic philosophy of science. And you know, wonder how you think about balancing between these competing interests of capturing the messiness of the real world and you know, kind of highly controllable hypothesis-driven research standards. So yeah, curious to see what you think.
Maybe I take this one first. So no, I mean, this is another really like difficult question, right? And I think the easy answer is probably to say like, well, we need both, right? Like, of course, on the one hand, like you can have these really large scale data sets, and with that, you maybe like really capturing a lot of like the diversity of different like representational spaces. One thing that like one recent lesson that we started to learn from like these benchmarking initiatives is that, well, it turns out that a lot of models are actually performing roughly equally well at like predicting like, let's say, fMRI data or human behavior. And that's really frustrating because we kind of were hoping that like, oh, we can actually learn something about the architecture that's relevant, or we can like learn something about like what kind of data we need and like what kind of, I don't know, like training objective. And it just turns out that like, oh, just throw a bunch of data at your problem and you get like really good performance, right? So that's like really frustrating. And I think that's where like really targeted kinds of experiments can really come in, either like classically designed, or, and that's something I'm a huge fan of, is like using these kind of contrastive methods, right? The way you really like try to focus specifically on those methods that will allow you like to distinguish between different models. And this is not necessarily like limited to deep neural network models. In principle, you can actually use this to automate like your experimental design process for even like classical experimental designs, right? So you can try to figure out like, how do I find those parts in like the stimulus space that actually I should be really like sampling to understand like much more about the things I actually want to learn. So so essentially, I think there's three kinds of different approaches. One is like the kind of like broad sampling. Let's have a look. Let's get like build models. Let's predict. The other one is like, no. We need like fine-grained experiments. We have like specific hypotheses you want to be testing. And the third one is maybe like a bit more like adaptive, targeted, like towards like figuring out like what actually like the discriminative, the most discriminative kinds of stimuli that we want to be shown to people in order to learn the most.
Yes, yeah, I agree with what Martin said, a challenging question, and there's so much at play here. So I think what comes to mind for me, like thinking how to keep a balance or strive for some balance between the rigor of a benchmark and its specific parameters, and then the heart of the research problem and its long life ahead, to not overdo, or really it's this double-edged sword I think I was trying to describe earlier as well. So on one hand, like one practical thing that we did when Ego4D, and many benchmark efforts would do, is like early development of baseline models. So meaning, when we were preparing the data annotations, we had researchers on the team developing early models that could try to, give a first take at these tasks. And early, I'm emphasizing because, the earlier that's done, the better chance we have to discover either flaws in the way we formulated the exact task or the annotations, or if we did really good, we might find shortcut ways, like unintended shortcut ways that this task could be solved that we didn't really intend. And so the more of that work that can happen in a kind of in a setting where you don't have a horse in the game, or whatever the expression is, dog in the race, where, because it was more like, let's just see what the current models would do if we did the intelligent thing now. And it wasn't so much like we're trying to sell a certain model for that task. So that's a good time to be doing that kind of work. So that's one thought that's very practical. Another one that also practical is that when we're developing these benchmarks that say come hand in hand with data, to make it as accessible as possible. And here I'm referring really to computation and storage limits that any given lab might have. And this is in tension with where data sets go when they're going very large and where volume is important. But ways to do that happened in Ego4D were kind of pre-computation of features, sharing out of kind of intermediate results and features that would be remove certain loads from downstream tasks and labs that want to use them. Also kind of the way, even just simple things like the way we prepare the data and the visualization tools we give with it, knowing that not everyone's going to download 3,000 hours of data, but when they have a certain research challenge in mind, they might want to peruse the data. And so we use things like the narrations I mentioned in the talk, as well as just good, well-developed visualization tools to search the data as a way to try to help that accessibility. And then the final thing I wanted to mention there is maybe an important thing we can keep our eyes on is like the evolution of benchmarks and data sets. Again, it's this balance, like you want to freeze something, so you have some non-moving target, to watch the field improve. But we can start thinking about evolving the data set, whether it means growing them, addition of labels, and really what's at the heart, at least in our work, is the data itself. Like the tasks some will thrive, some will fall, and we'll realize they weren't what we thought, and that's okay. But if the shared data resource itself remains useful to people, and that's even something we can grow well, then that's something that might persist even longer than any tasks that we've dreamed up so far.
Fantastic. Thank you both. Okay, and that brings us to the end of our discussion and the end of our seminar today. So I just want to give a huge thank you to both Martin and Kristen for joining us here today for two really incredible talks and for very lively, thoughtful, and engaging discussion. Thank you.
Yeah, thank you.
Thanks.
Thank you for
On the
putting this
right
together.
time.
Thank you so much for having me be part of this. Yeah, this is great.
Yeah,
It's really nice to meet you.